Today we're going to talk more about microphones. From the last lecture, we know that microphones are transducers that changes sound energy into electrical energy, that is, turning sound waves into electrical signals. Quality of the pickup of microphone depends upon its design variables such as the mechanism of the microphone and the material used, and also depend on external variables during a recording session such as placement, distance, and acoustic environment. In this video, we will cover 3 different types of microphone: dynamic, condenser, and ribbon. The type that perhaps we use the most is dynamic microphone, sometimes known as moving coil. It operates by using electromagnetic induction to generate an output signal. Electromagnetic induction is whenever an electrically conductive metal cuts across the flux lines of a magnetic field, a current of specific magnitude and direction will be generated within that metal. This is a stiff mylar diaphragm of roughly 0.35 mm thickness. 0.35 mm is about 0.000889 cm, that is 8.89 micrometer. These are not beads, but instead the cross-section of the coil. The coil is attached to the diaphragm, suspended within a high-level magnetic field. Whenever a sound hits the diaphragm's face, the attached coil is displaced in proportion to the amplitude and frequency of the wave, causing the coil to cut across the lines of magnetic flux that is supplied by the permanent magnet. Dynamic microphones are durable, that is why it's widely used in live performances. It will not break easily even if someone has dropped it on the floor. It is usually at a reasonable price, but it is not very sensitive because when the sound wave hits the diaphragm, the coil moves together with the diaphragm. Therefore, the microphone could not capture small details due to the inertia of the mic. The second type is condenser microphone. Thickness of the diaphragm is 50 nanometer. Due to its extremely low mass, the diaphragm can follow the sound waves more accurately, meaning it can respond to details. Condenser microphones need a 48-volt phantom power to boost up the signal before it leaves the mic. Almost all microphone inputs offers a 48-volt phantom power, so remember to turn that on when you're using a condenser mic. Instead of a coil, ribbon microphone uses a thin aluminum of electrically conductive ribbon placed between the poles of the magnet to produce a voltage by electromagnetic induction. Since the piece of ribbon is extremely delicate, ribbon microphone is used only in recording studio for recordings of instruments. It needs to be handled with care because it could be easily break by sudden change in air pressure, humidity, and dust. Some people think the pickup of a ribbon mic is sweeter and warmer because there usually has a decline in high frequencies, that is missing high frequency details.